Welcome back to the deep dive. Today we are taking you right onto the factory floor. Our sources for this are basically a super detailed itinerary for an executive tour of a high-tech facility. They specialize in rugged computing.
Right, rugged tablets specifically.
Exactly. So we're going beyond the glossy brochure and really getting into the weeds of how they do things.
That's right. And we're looking at a niche where, failure just isn't an option.
The sources even start with a welcoming committee: Steve, Andrew, Jesse from a company called Cineva. And they mention these little hospitality touches. It really sets the tone,
Yeah, like Chinese branding, lucky coffee for a wake up.
right? And a very specific location: fourth building, fourth floor. It all points to a meticulous, highly organized place.
So, our mission today is to figure out how a company in this kind of high stakes world builds products that just refuse to break and what systems they use to guarantee that reliability.
It really starts with who they're building for. The client list tells you everything, doesn't it? Their primary business is clearly focused on these extreme mission-critical applications.
hmm We're talking about devices for car and vehicle diagnostics. And then you see these huge names like BYD for electric vehicles, big oil corporations, coal and mining companies.
And when your tablet breaks down in a coal mine, well, that's not just an inconvenience.
No, it's a huge operational failure. It could cost a fortune. So they're not really selling a tablet,
What are they selling them?
they're selling reliable uptime in really hostile environments. That's the whole value proposition.
Okay, so let's unpack this. Starting with their credentials. They've been around since 2010. So over a decade in a very specialized field, and they make this huge claim positioning themselves as and I'm quoting here, top supplier, offer top quality and highest IP68 waterproof durability reliability in whole industry.
HEST, meaning best, I assume. Think so. It's a bold claim.
Well, if you're going to say that, you have to back it up,
And they do. They start with the basics like ISO 901 certification, the international standard for quality management.
right? But for their clients in, mining or defense, the real currency is that long list of certifications. It's an alphabet soup. CHS, FCC, explosion proof, IP68. And the big one, MIL STD 810H, that military standard, that's the gold standard.
Isn't it? It's the absolute benchmark for durability. Yeah, it was established by the US Department of Defense. Well, what does the H at the end actually guarantee someone, a foreman in a freezing warehouse?
It guarantees survival. It's not just a simple pass-fail. It forces them to test the device against this huge range of environmental stresses like what?
Mechanical shock, intense vibration, high altitude, thermal shock, so rapid swings in temperature, even things like fungus resistance.
Wow.
It's a certification that moves the device from being just commercial grade into that mission critical space. And it seems like their R&D is top-notch too. The notes mentioned their R&D center got a US Industry New Design Award.
Yeah. For developing a new tablet, and they even named their competition the GUTAC F110 model. Citing that model is very deliberate. It's a competitive benchmark. It shows they're aiming to beat the absolute best in rugged design.
So, before we even get onto the assembly line, there's another marker of their obsession with quality, the safety here.
Yep. You have to put on static-proof clothing and a dust-proof case, which is non-negotiable.
It's about protecting the components from us, from the dust and static we bring in. It just shows that quality control starts before the first screw is even turned.
Absolutely. The environment itself has to be perfect. All right, let's move into the heart of the operation, the assembly process. Our sources say it's over 20 steps.
Over 20 assemble progress. Yeah, but they immediately focus on the most critical part, the IP68 water resistance gauntlet, which every single unit has to pass before it ships. No exceptions. This is where they prove that HEST IP68 claim.
And to do that, they use a specialized glue drip machine for precision sealing, right?
And then they have a mandatory two-stage testing process. Why 2 stages? If you dunk it in water and it doesn't leak, isn't that good enough?
Not for these kinds of applications. The 2 stages are designed to catch different kinds of defects. The first test is invisible.
Invisible.
Yeah. It's non-destructive. They use air compression to test for air pressure leakage. So they pump air into it. They pressurize the inside of the tablet. If there's even a microscopic flaw in a seal, the pressure will drop. It finds invisible weaknesses that would absolutely fail out in the field later on.
That's smart. You catch the problem before water even gets near it.
Exactly. And only after it passes that test do they move to the visual one.
Der Danktank.
Basically, they dip the device into water and watch it. If any bubbles rise, it means air is escaping and water is getting in. And that's an instant fail.
Instant rejection.
Passing both of those tests is what ensures the comprehensive integrity of the seals. It's like a belt and suspenders approach. A high-tech invisible check and then the most basic visual one.
And what kind of volume are we talking about? This sounds slow.
You'd think so, but they maintain some serious throughput. The line can produce up to 500 units per day.
500 across 2 shifts. Wow, that's significant for such a niche product.
It shows they've engineered their process for both quality and speed. That scale is the perfect transition to how they track everything, managing 500 units a day across more than 20 steps. It would be a logistical nightmare with paper checklists.
Right, and this is where they have what the notes call their crucial invention, the digital display online monitor system. This is their secret weapon.
It's not just a big TV screen on the wall. No, it's a dynamic real-time feedback loop. It's all about accountability at every single one of those 20-plus steps.
Okay, so break that down. How does it work? How does the data get from the worker to the main display?
So at every station on the line, the staff member has their own small programmable tablet, a subtab. Exactly.
When they finish their task, let's say installing the display housing, they log it as a complete on their tablet. The input is immediate.
So every worker is basically timestamping their contribution to a specific unit precisely.
And that data instantly feeds into the big centralized dashboard. So for a manager, it's like a living map of the entire factory floor. They can see bottlenecks in real time instantly.
They can see which order is stuck at which step, who worked on it last, and how close they are to deadlines. It's all real-time production data.
That's a huge leap from, a supervisor just checking work at the end of the line.
It makes quality an integrated part of the process, not a final check. And it forces immediate accountability and problem solving. And beyond the main assembly.
There are other lines, customization, laser printing logos, and the aging room tests.
Right? Where they run the completed devices to check battery life and just general stability. It all culminates in the final audit trail.
Before anything leaves, it gets a formal quality certification with a SEN number and an IME number.
Which for their corporate clients are essential. It's a permanent traceable record for inventory and warranty.
Okay, so we've built the devices, we've sealed them, we've tracked them digitally. Now we get to my favorite part, the torture chamber, the product testing laboratory.
This is where they prove the business model. This is where they separate the tough from the consumer-grade stuff. And these tests are brutal, specific, and designed to simulate the absolute chaos of a real-world work site.
Okay, give me some specifics. What are they actually doing to these tablets?
Let's start with impact. They do a metal ball drop from 1.2 m to hit the screen.
Ouch.
And that height isn't random. It's calculated to simulate a drop from your hands onto a concrete floor. It's a controlled catastrophe. And the environmental tests must be just as bad. They are.
They have an extreme temperature chamber. It runs from frozen 20 Celsius up to a blistering 60 degrees Celsius. That's -4 to 140 F.
That kind of temperature swing would destroy most electronics. It puts incredible stress on the components, the circuit boards, and especially those IP68 seals.
If it fails in that chamber, it'll fail in a Siberian winter. What else are they throwing at these things? They have machines for impact, shake, and collision testing.
It's meant to replicate the constant vibration of being in a truck or on heavy machinery day after day.
For years. And they also specifically do a salt corrosion test on the outer shell, which is critical for anything used near the ocean.
Or even just on roads that get salted in the winter. If the casing corrodes, the whole system is compromised. And the most incredible metric here is the speed.
They claim they can simulate years of usage in just a few weeks. That's essential. You can't wait 5 years to certify a product that's designed to last 5 years.
They use accelerated testing to compress that wear and tear into a short, intense cycle. So we have these ultra-durable, torture-tested products.
Right?
But that's useless if you can't get them to the customer quickly, right?
Durability has to be matched by efficiency, and their warehouse seems just as advanced.
It is. They use an automatic warehouse management system and they track all their inventory in real time using RFID technology, radio frequency ID, so no manual barcode scanning.
No, it allows for instant tracking of every single component and finished unit. They know exactly what they have and where it is at all times.
And how does that translate into speed?
It means they can process and ship orders within 24 hours. Wow.
So if a client suddenly needs 100 new units, their automated system can fulfill that demand almost instantly. And what about the units that fail all those tests?
They have a strict protocol for them. Any inspected defect material gets marked with a big red label.
And then what?
It's completely isolated in its own section. There's zero chance a compromised part accidentally re-enters the production line.
Is quality control right down to the trash bin? This has really been a complete picture from the need for durability in an oil field all the way through a metal ball drop and then being shipped out in less than a day.
The key takeaway is that, for them, reliability isn't just a feature, it's the entire business model.
Right?
And it's forced by that hyper-detailed digital tracking system and confirmed by the brutal honesty of the testing lab.
So the tour highlighted how they can simulate years of usage in just a few weeks. And it got me thinking, if this level of intense documented accelerated testing is what it takes to actually prove reliability for rugged devices.
What does that say about the products in other industries, the ones without all these certifications? That's a really interesting point.
What assumptions about durability and lifespan might we be taking for granted every single day with the tech we use?
It makes you wonder, right? Without the torture chamber, how can we really judge resilience? Something for you to consider next time you look at a device's warranty.
And that's all the time we have for this deep dive. Thank you for joining us.